Okay. Greetings, everyone, and welcome into my channel. I am Professor L, and this is a live stream for math help. So, if you need help with your math and you happen to be watching, you're welcome to put a problem in the chat. And I will, if I don't know how to work it, I'll just tell you I don't know how. But get back to you or something. But if I do know how, I'll stop whatever I'm doing and work it for you. Yeah, so happy Thursday. And yeah, so I'm just going to get right into it. Reflecting on yesterday, I am a little bit embarrassed that I put a hyperbola up here and I didn't really know all of the technical details of that hyperbola. Is not not much, but I was able to successfully sketch the graph based on, that old brute force method where you just, you build a table, plug in values from your domain into your function, and then find out the behavior of your graph. Um, Whether you know anything about a function or not, you can successfully graph almost, I would say, any function in the world by that method. So we were able to get mission accomplished. However, I realized that there's a lot I don't know about hyperbolas. And it was reminding me of these other things called ellipses. And so just playing it by ear. I think the figure of speech is flying by the seat of my pants here a little bit, just wanting to not really plan too far ahead about this live stream and the content in here. Just trying to, play it by ear. Maybe that's a better one. And just, day by day, trying to pick random topics that I want to explore in mathematics on my board. And what I've decided to do is today is to go ahead and I'm going to look, my circle looks like an ellipse. That is not good enough for me. So I definitely do want to practice. But yeah, just a little reflection from yesterday. And then I'm going to go ahead and get into my new system that I have. It is a parabola and an ellipse. So graphing ellipses are kind of similar to hyperbolas, where they have a lot of extra, like they both have, I believe, a directrix and vertices and foci. They also have an eccentricity. So there's a lot of things that are common about evaluating the graphs and of those. Yeah, I wouldn't even call them functions because they don't pass the vertical or horizontal line test, but they would be relations. And so the graphs of those equations um, essentially are very similar when you're going to analyze them. So I decided that I wanted, because I have this other system that is consisting of an ellipse and a parabola, I would go ahead and sketch it. And what I want to do is in the very near future, try to learn, like the next day or two, try to learn a little bit more about graphing and all of those. There's a lot of definitions. Like I'm not even sure exactly what the directrix does or what the significance is. And I read the definition yesterday, and I was just like, okay, I got to go and figure out what a transversal in that context is, because I understand like a transversal is just a line that intersects another line. But yeah, anyway, so let me go ahead and focus and digress and go ahead and write this system up here that I picked out. It's an ellipse and it's parabola. And x squared minus 4 and buy me a little bit more time to research some of these definitions and values on the hyperbola before I go and even try to attempt the graph of one, which I really want to. Y-squared. And I'm going to throw myself under the bus a little bit here and say that I don't remember a lot of the technical details on how to find these values on the ellipsis either. There's foci, and there's a directrix, and there's a center, and there's vertices. And I don't know how to find those values. There are formulas and it is a method, so I would just have to go and like refresh my memory, because at one point in time in my life I did know and I was responsible for that knowledge, but yeah, so I had forgotten it. But that's okay, because what I don't need all of that to sketch an accurate graph of this of either one of these equations. And so I'm going to go ahead and get my Cartesian coordinate system out. Go ahead and sketch that. Get it ready. I don't have any idea where the party is at on this graph yet, because I haven't even had a chance to look at this function at all. It's a busy or hectic world, and so part of me offering up this space to students is me, taking advantage of the time to spend on the math, because there's so much to do and only 24 hours a day to fill. All right, so looking at this system, I can solve this algebraically and find those values. But what I want to do is I want to go ahead and just sketch their graphs, I think, first. So we've got this one first. It's y equals x squared minus 4. So this is going to be your parabola. And remember the conic sections that we talked about yesterday. We have the parabola, the hyperbola, the ellipse, circle, and was that all of them? Hang on, I have this pulled up. Let me click on it. Does it list them? And it has to do with the cross section of a cone, and that's why they're called conic sections. But I am not going to spend a whole lot of time going into the theory of the conic sections again, because I want to do that at a later date. I started to today, and then I chickened out because I'm just too tired. So parabolas, ellipses, circles, and hyperbolas. And I want to get better at graphing the hyperbola for sure. All right. So I am going to go ahead and sketch the graph of this one, and I'm going to focus on my parabola first. So let's come over here. I don't think I need a very big table, but we'll go ahead and just put one in here. And understanding the equation of the parabola, y equals x squared plus or minus 4, what it boils down to is taking the basic general graph of that function, which would be having a vertex at 0, and just understanding basic transformations, you can just shift the graph down 4 units. Because that's what this -4 value is doing. It's taking the basic general graph with no other transformations involved and shifting it down 4 units. So I have this y-intercept. It happens to be the minimum value of my graph. And I can find that very easily by just plugging in 0 here for x. So we'll take this function y equals x squared minus 4. When x equals 0, you're going to get y equal 0 squared minus 4, which is minus 4. So now what I want to do, since I have that value on there, I'm going to go ahead and plug in 0 for y now. And solve this thing for x. So 0 equal x squared minus 4. And just replacing 0 with y. And so it's going to give you x squared minus 4 equals 0. And just add 4 to both sides. So that's going to give you x squared equals 4. Then to solve a square for the inverse, you just take the square root and you get plus or minus the square root of 4, which is 2. So we have two values. We've got plus or minus 2 here. The y equals 0. I'll bring it a little bit further out. One of these days, I'm gonna do it perfect the first time, so I won't have to erase 20 million times. And we'll probably need some more values on the graph. I'm just looking to see if that looks somewhat symmetric. So such a big deal. Okay. So we've got those. I'll draw them in there. And so let's see. Do I want to find any more values on? Okay, that's probably good for now. We'll go ahead and draw that in there. And just to verify that point, we'll go ahead and see what's going on at negative, positive, and negative 1. So we'll just plug in for x equal negative 1. And we've got y equal negative 1 squared minus 4. And it's going to give me 1 minus 4, which is negative 3. So at positive 1, negative 1, we've got negative 3 on the graph. Well, negative 1, negative 3. So it looks like it's just a little bit more skinnier. There we go. And if I don't draw, I just erased the wrong one. If I don't draw and do my best to get as accurate of a sketch as I possibly can, then I run the risk of future failure because when you're trying to solve these systems graphically, and then you don't have even have graph paper, that it's a really that is, you know, you're not really doing yourself any favors. Trying to be, you're not setting yourself up for success, put it that way. But again, this is just me playing around with these concepts and trying to make the most of my time getting familiar with this format. You'd be surprised, because I've spent the majority of my adult life avoiding social media and cameras. So going, head first into both of those things is a real challenge for me. So, all right, so we've got that. I would like to kind of see what's going on up here in my first two quadrants. So it looks like it's expanding this way. So if I want to find any more values, it looks like in positive land, we're going to have to go ahead and go out a little bit further. So let me see if I can just draw these in here real quick. And 4 and -4. And this is really good. And one of the reasons why I picked this function was because it's going to give me a little bit more practice sketching the graph of these parabolas, because eventually I do want to get into some of the applications and look at some of those falling body or projectile motion problems. And there are a lot of applications that are really fun physical concepts to work out. So just getting a little bit more practice. And also I wanted to do something with an ellipse too. So yeah, that's the reason why I picked this system. All right, so let's go ahead, and so we know what's going on in positive -2. My table is so out of order. We'll fix it later. So we're going to do plus or minus negative, or yeah, plus or minus 3. Let's do plus or minus 3. And you notice the symmetry, because when you square a negative, you get a positive. So you're getting the same result, the positive and negative. That's why I'm kind of condensing my table. All right. So we've got x equal 3. Do -3 just for fun. So this is when x equals -3. Y equals -3 squared minus 4. That's going to give me 3 times 3 is 9. Positive 9 minus 4 is going to give me 5. Okay, so I've got this at plus or minus 3. I'm at 5 now. Wait, this was -3. Let me make sure I got my details. That was -3. Wow, we're already up all the way up at 5 at -3. So that might be good enough for me. There's 1, 2, 3, 4, 5. Okay, that's going to be sufficient. Okay, I think that will do. I'm just going to check the symmetry. It looks like it's we're getting a little out there here. Let me tighten it up. And let's give this one just again, if I'm not careful, then I could run the risk, and I don't want to be too sloppy. I don't want to take the fact that it's a rough sketch for granted. I want to still do as nice of a sketch as possible. Right, so we've got the basic general graph of my parabola sketched here. We're going to go ahead and erase some stuff. Oh, I've been talking already 20 minutes. Good. So I am, get the eraser and go ahead and erase all of this, and then start looking at this ellipse. And just like that hyperbola yesterday, it does have a standard form. And it has to do with making this number the quantity 1. So let's see what we can do. So we've got 3x squared plus 8 y squared equal 75. And for now, what I want to do is, well, just like the hyperbola 2, where it can have an orientation, so it can have, let's sketch a basic graph. So like that hyperbola yesterday was like this, and this is a horizontal orientation. That's what it's called. You can also have a vertical orientation where it's like this. And ellipses are the same way. I need my eraser. Ellipses are the same way. So there is a theory involved in figuring out whether the ellipse, because you're thinking it's more like an egg shape. That is not symmetrical at all. I'm hoping that the one that I draw, so this would be a vertical orientation, a horizontal orientation ellipse. And excuse the rough sketch because I know that does not look near like it's not symmetrical, but if you could imagine a symmetrical object. All right, hopefully more to come on ellipses and hyperbolas, because I realized that I want to know what all those words mean, so I have to relearn. Okay. But for now, what I can do is I can go ahead and build a table and figure out where at least my y and my x intercepts are by making x and y 0 simultaneously. So we have x and y, and we'll just plug in 0 for both of them and see what happens. So if you want to find your y-intercept first, you could make, we'll make x 0 first and solve it for y and see what happens. You should have 2 intercepts, just so you know. So we're going to go say 3 times 0 squared plus 8y squared equal 75. Just plugging in 0 for x equal 0 into this function. All right, so we've got 8y squared equals 75. And I don't know if I don't think that divides evenly, but let's make sure. It doesn't, that's okay. So we've got, so we're going to divide off the 8 from 75. And we're going to get y squared equals 75 divided by 8. And then you're going to take the square root to solve for y. And that's going to give you y equals plus or minus radical 75 divided by radical 8. And rules for radicals. Neither one of these are perfect squares. You can simplify them a little bit. So 75 is 25 times 5. Wait, times 3. Times 5. Getting a little ahead of myself there. 25 times 3 over the square root of 4 times 2. So what you would do is you would pull out the perfect squares from that. So that's the square root of 5. And then you have radical 3 left over. And pull out the perfect square root of 4. That's 2 radical 2. And then at this point, what you could do is rationalize. So you've got radical 2 over radical 2. And that is going to equal 5 radical 3 times 2, which is 6, over 2 times radical 2 times radical 2. It's 2 times 2, which is 4. Right. So we've got plus or minus this thing. So when x is 0, we've got plus or minus 5 radical 6 over 4. Okay, and then I have to figure out what that is. 5 radical 6 over 4. Let's see. We'll just plug it into the handy dandy calculator. It's saying 3.06. 1, 8, 6, 2, 1, 7, 8. And put all those digits in there that the calculator gives you. So it looks like when x is 0 here, we've got y at approximately 1, 2, 3, 4, 5. It's going to be right in here, a little bit more than -3, because this is plus or minus here. And it's going to be right above 3 here, just making it big. All right. And then let's see here. All right, that looks good. Okay, just trying to see visually. All right, so let's go ahead and plug in now 0 for y and see what happens. Okay, so we've got into this one here. We'll do it here. So that'll be 3x squared plus 8. Get out of the way. 0 squared equal 75. And so that's going to give me 3x squared, 8 times 0 squared 0 equals 75. And then we can divide off the 3. And that's going to give me x squared equals 75 divided by 3 is 25. Because if I have 3 quarters, I have 75 cents. All right, so we are going to take the square root of both sides, and it's going to give me x equals plus or minus square root of 25, which is 5. So we have when y is 0, x is plus or minus 5. And we knew there's going to be 2 of those values. So plus or minus 5. When y is 0, so we're going to get 5 on there. Because we have clean intersections here. And so I want to decide here. So we have, make this a little bit cleaner. That line, this is a perfectly horizontal line. It doesn't look that way. So there's 4. I'm tired today. I was so tired I didn't even know. I was like, am I going to be able to do my live stream? But I'm better. Waking up. Getting a second wind, I guess. All right, so I want to go ahead and put these points in here. And I don't know if I want to go ahead and just like eyeball it, or let me just think for a second. Let's go ahead and plug in some of these other values in my domain, because I know that I have this. I have all of these values because this is my intersection. And I do know that I think that this ellipse is centered at the origin because of the graph. I didn't put the general equation up here because I was going to butcher it, so I don't have it handy. I would have to look it up anyways. So what I'm going to do is I'm going to pick some other values within the domain of this function and see if I can't find some intersections in there. So I am going to pick, let's see, we did -5 and it's about 3. Let's do -3 in the domain. And yeah, so go ahead and erase some of this stuff. So we're still playing around with the ellipse function. Graph a couple more points and then we'll go ahead and find those intersections algebraically. I don't know if they're going to be clean intersections. I mean, there'll be clean intersections there. They might not be clean numbers. Okay, you might have some ugly decimals or fractions to deal with. But let's go ahead and plug in and see what's x is plus or minus 3. So we'll try x equal -3 first. We'll have 3 times -3, y squared plus 8, y squared equals 75. And -3 squared is 9 times 3 is 27. So that's going to give me 27 plus 8. Y squared equals 75. And solving for y, subtract 27 from both sides. That's going to go to 0. We're going to be left with 8y squared. 75 minus 27. 53, 52. 71. And 48. I was way off. Good. I double checked. 48. And then divided by 8. Is that 6? 48 divided by 8. So y squared equals 6. Remember my division tables. Sometimes I forget my middle name. I get too stressed out, so I'm going to calm down. All right, so y squared, because this is just for fun for me. And while it is a little bit stressful because of the, learning curve and everything, it's good stress. So definitely not going to complain about getting to do math. All right. On this big, pretty whiteboard that I have. All right, so we have y squared. Taking the square root is going to give me y equals plus or minus radical 6. And radical 6 cannot be reduced. So that's just a value. So we can plug in the calculator and figure out what that is. But that is, if you think about it, it's right between, so the square root of 4 and the next one will be the square root of, hang on, no, it would be, so radical 5, radical 6, radical 7, radical 8, and radical 9. So we got perfect roots, and we've got 6 nested between the value 2 and 3. So all of these other roots must be existing between 2 and 3. So we've got 6 right in the middle, so it's probably about 2.5. But that's how you would estimate the root if you didn't have a calculator. and it says it's 2.449. Just having a little bit of number sense. I might not be the smartest person in the room, okay? I'm not trying to be. I just want to have good number sense, and I want to be the best that I can be. If that makes sense. All right, 2.449 489,743. All right, good. So we have this point. Where is my table? Did I erase my table? Okay, let's put it back in here. I'm a little happy with my eraser. So we had 0, 0, and we plugged in -3, right? And we did plus or minus because it's going to give us the same value. And we got this plus or minus radical 6. And then when I had 0 for y, I got plus or minus 5. And then when I plugged in 0 for x, I got 3.06, but that was okay, I can't believe I did that, but maybe I'll remember in a second. Okay, so we've got these other values on here at plus or minus -3. We've got plus or minus radical 6, and we figured out that was 2.44. So we could go ahead and put a couple more points on here. At -3, we've got plus about 2.5. It's probably right in here. Got this value right here. And then we also have the negative aspect of radical 6, which is right in between 2.5. So we've got this other point over here, right here. And then we'll do +3 as well. Because these ellipses, when you sketch the graph, you locate the center and you locate the intercept, and what's happening is it does have a symmetry about the x and y axis. So that's why you're getting all these points in common. It doesn't have the same symmetry like circles, but it does have with respect to its own graph. If that makes any sense. I do my best to explain it, but trying to explain such a complicated subject, and then also getting to watch myself on replay and reflect on how I'm explaining the math is very, very beneficial. And I realize that I do better than I think I do. So that's me giving myself a compliment, but I also realize that it's a little rusty in the explanations. So I feel like it's really good for me to just keep practicing and chipping away at it, because I feel like I'm going to get better. That was really rough. It's supposed to be a little bit more curvy. Okay, so here is my ellipsis, and it looks like I can kind of see these pretty intersections here. I don't know if these are actual intersections on my graph, but I have also these that I don't think I've calculated, and they look real close to -2. So this could be me not sketching the graph very well. So I see an intersection here, 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 and here, but I don't see those values. They're not clean to me. So what I have to do now is, now if I had graph paper, then I would have been able, I feel like, do a little bit better job. And it doesn't always work out that you can see those points graphically. So I don't technically have this system solved yet. What I need to do is I'm going to go ahead and solve the system algebraically. So I can go ahead and get that graph looks so ugly to me. But I just have to deal with it. Something I created. So. All right. And then it's bugging me that I don't remember this value. It was 3.06. I remember the decimal, but I don't remember it was like 5 radical, hang on, was it 5 radical 3 over 2 or something like that, or 4? It was 4, okay. Thank goodness. All right, so it was 5 radical 3 divided by 4 plus or minus, okay. Thought I was going to have to go recalculate that, which it's irrelevant at this time because I didn't have it marked on my graph. And we're already at 42. Let's see if I can just straighten it up about that. All right, I don't think there's any fixing that graph, but it's okay. Let's go ahead and solve it algebraically. And what we're going to do is we're going to look at all of those rules for solving systems, and they're very similar to solving matrices. But you can add the equations to eliminate a variable. It's called the elimination method, or you can make a substitution. And since I already have y equal to something, I think I'm just going to go ahead and go that method. So there is more than one way to solve problems. There's multiple. So it's just when you're thinking about the solution and the method that you're going to take, it's a very, it's an individual thing. Like you just figure out what makes sense to you and go with it. What makes sense for me is to take y and plug in what y is equal to into the other equation. So that's what we're going to do. So this is 3x squared plus 8 times x squared minus 4 quantity squared, and that equals 75. And all I did was, instead of writing y, I opened up parentheses and I inserted into the parentheses what y is equal to. So making a substitution. So I'm not doing any math magic here yet. All right, so now I'm just going to simplify this equation and combine like terms. So that's 3x squared plus, and in order of operations, I have to handle that exponent before I multiply that h. So I'm going to say, x squared minus 4 times x squared minus 4. And I'm going to figure out what that equals there. And then I'll write that right here inside that parentheses equals 75. So we're systematically making sure that each term gets multiplied exactly one time. So x squared times x squared is x to the 4th. And x squared times -4 is -4x squared. And we're going to take this value and multiply it here and here. So -4 times x squared is -4x squared, and -4 times -4 is plus 16. Combine your like terms. We have x to the 4th, 2 x squared terms. So add them, the coefficients. Keep your exponent, and then that's plus 16. And that's how you find the expanded form when you multiply two binomials. So we have x to the 4th minus 8x squared plus 16. And just erase this one here. All right. It should not take very long to do this. It's not near as long as the graphing. Graphing is impractical, but it's also it's relevant, so it's worth it. So we got 3x squared. We'll combine that term in a minute because we want to take 8 and distribute 8 across all three terms. So we've got 8x to the 4th minus 64x squared plus 8 times 16. So 8 times 10 plus 8 times 6. So 80 plus 48. So it's going to be a positive 128 equal 75. Let me make sure my calculator. Seeing is believing, isn't it? 8 times 16. Yeah. All right. And then we'll just add in the 3x squared here. And so that's going to give me 8x to the 4th. And then that is going to be 64 minus 3 minus 61x squared plus, in the same step, I'm going to go ahead and subtract 75 from both sides to set it equal to 0. Because that's how you solve higher order polynomials. And 128 minus 75 is 53. So that's going to be plus 53 equals 0. All right, so what I'm hoping is, oh, it doesn't factor. That's okay. So what we'll do is we're going to practice a little u substitution. And we're going to practice the quadratic formula. Because there's no way this factors, I'm pretty sure 53 prime 61 for your square term. So it's yeah, there's no way. All right, so we're going to go ahead and set u equal to x squared here. And then you can rewrite this term. This is 8x squared minus 61x squared plus 53 equals 0. So I'm going to rewrite this. This is 8u squared minus 61u plus 53 equal 0. And so we've got a equals 8, b equal negative 61, and c is going to equal positive 53. And really wish that I had batteries in my other calculator because I have the quadratic formula and right now I'm being really lazy, not wanting to do it, but we'll go and do it. So we have u equals plus or minus, not plus or minus, it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so hardest part of the quadratic is plugging in. You just, after that, you just simplify. So it's going to give me a positive 61 plus or minus the square root of, a little bit of algebra here, 61 squared is giving me 3,721. And then 4 times 8 times 53. And then there's no negatives, it's going to be negative 1696. And that's all over 8 times 2 is 16. See, I think if I crouch down, I can get here. A little bit of space on here. There's room. So we've got 61. Let's see. Let's figure out 3721 minus 1696. That's cool. It was 2025. That was last year. Okay, so 61 plus or minus the square root of 2025, which I think might be a perfect square. And let's divide it by 16. 61 plus or minus. It is cool. So that's plus or minus 45 over 16. So we're almost there. So we've got 61 plus 45. So we've got 61 plus 45 over 16 and 61 minus 45 over 16. So finally we have 106 over 16, and this one is 106 divided by 16. 53/8. So this one reduces down to 53/8. So we'll circle that one. And then this one. Oh, nice. That's 16 over 16. So that it reduces down to 1. Nice. So that tells me that it did factor. I just couldn't see the factors, which is okay. So back up here, right here. Okay. And I got some room down here I can work. So we had this 8u squared minus 61u plus 53 equals 0. So we solved this, and we got u equal 53 over 8 and u equal 1. Well, if I want to rewrite that factor, we would say multiply both sides by 8 here. And that becomes 8u minus 53 equals 0. And then this is u minus 1 equals 0. But I think that all we need is this one. And we're going to go ahead and replace. So since we have what u is equal to, we make a substitution. We'll turn around and plug x squared back in at this point. Equals 53 over 8. So when you take the square root, you're going to, for this one, you're going to get x equal plus or minus radical 53 over 8. So let's put it up here. X equal plus or minus radical 53 over radical 8. And then the other one, x squared equal 1. So this is x equal plus or minus 1. So here's your solution for x, your x coordinates. So what it's saying is, let me see where radical 53 over 8. It's saying at approximately 2.57 up here. And x is here. Plus or minus. So hang on. .57. That's here. So it's saying when x is plus and minus. So here and here we have, and then also plus and minus 1 here and here. Bottom right here, right here, right here, and right here. All right. So what we have to do is, now that we have x here, and we have x here. We'll set up our ordered pairs. There's one here somewhere. Here somewhere, right? And here somewhere. We're going to set up our order pairs. We already have our x values. So x is plus or minus radical 53 over 8, which is it's going to be here and here. All right, let's just figure this out. So we got plus or minus 1. So that's this one. So it's probably x is positive 1, x is negative 1. And then this one's probably the 53. Make that a little bigger. Radical 53 over radical 8 negative. And radical 53 over 8 positive. And then now what we have to do is figure out, or since we've done all of this work to find x, now I have to erase. I cannot believe I've already been talking for an hour. But that's fine. I want to finish this. And I think about the stuff that I want to talk about. I have no idea how long it's going to take me. So this stuff is not overly complicated in the grand scheme of things, but it is an advanced topic technically. So it's definitely not simple math for sure. All right, so let's go ahead, and what we're doing is it doesn't matter which equation I use. I want to use the most simple equation, but really all I'm trying to do, I've already did the hard part. I figured out my 4 values in that domain. So now all I have to do is solve for y at those 4 values. So I'm just going to use this top equation. So we'll say y equals x squared minus 4, and we'll plug in. And it's going to create some symmetry. We won't have to do it 4 times because we'll have to do it twice, because when you square a negative, you get a positive. So this is going to be y equals at radical 53 over radical 8, y squared minus 4. And my marker's starting to dry out, so it's getting a little sloppy. When you square a square root, you just get the number back. So that's 53 over 8 minus, and then what I'll do is I'll just make a equivalent fraction in one step. 32 divided by 8, which is negative 4. So it makes it a little bit easier. So 53 minus 32. is 21. So I've got 21 over 8. So here, this should be 21 over 8. So 21 is about 2.65. So here it is, 21 over 8. And then this one's also should be 21 over 8. So we've got those two. And then one more time, y equals when x squared minus 4 when it's 1. We got 1 squared minus 4. So that should be 1 minus 4. So that's going to put me at -3. So we should be right here at -3 in both places because of that symmetry. Perfect. All right. Well, that was not easy. And that was not short. But I was successful in accomplishing my goal, which was to graph the system and solve the system, and got a lot of practice in my math calculations and my drawing. And so I'm happy. I'll count that as a win. And yeah, so it's Thursday, so we got one more day live streaming tomorrow. So just depending on what I feel like doing, I haven't decided yet. We'll play it by ear, and hopefully I'll figure out something cool to do tomorrow for Friday. And yeah, so if you are tuning in and you're watching my videos, I really appreciate it and just want to say thank you. And if not, then oh well. But yeah, we'll call it good, and I will be back tomorrow at the same time, same place. So if anybody needs help with their math and they want to tune in, I will be here between 6 and 7 p.m. Central. And again, this is Professor Al, and I'm signing off, and I'll see you next time. Bye.